Welcome to PreCalculus, Section 8.6, on partial fraction decomposition. This is part 1 of our lecture. So partial fraction decomposition means breaking one fraction into the sum of several fractions. We know how to add fractions by finding a common denominator, and we've done that with fractions that not only have numbers in them, but also have variables in them. So for instance, if I were to add this fraction plus this fraction to get this fraction, I would have to first find a common denominator for both of these fractions before I could add these two fractions together. So we've learned to do that. So I would have to multiply by some form of 1 so as not to alter the original fraction. So I can see that my common denominator has to involve both of these factors multiplied together, and it would look like this. So in order to get this x plus 2 in the denominator of this fraction, I'm multiplying by this form of 1. Therefore, I then would have x plus 2 times x plus 1 in the denominator. And I would do the same thing to this fraction here in order to get the x plus 1 in the denominator. I would multiply by this form of 1. So now what I would have to do is say x plus 2 times 1 plus 3 times x plus 1 is our new numerator, and then of course we would have this common denominator, x plus 1 times x plus 2. So that would look like this right here. So if I simplify this expression here, I'll then get this 4x plus 5. So you could see if I go ahead and follow out this simplification, I'm going to get this 4x plus 5. So what we've shown is that we can go forwards, if you will, by adding two known fractions together, finding the common denominator first, and then simplifying. What we're going to learn how to do now is to go in the other direction. If we're given this result, a fraction like the end result we would have here, how do we get back to the two fractions here that added up to give this fraction here? So we're going to learn this process, and the process involves solving a system of linear equations, which we learned how to do in 8.1. There are a few rules that we want to lay down first before we get started. First, we need to factor the denominator completely. So we want to factor the denominator into what we call irreducible factors. So this word irreducible means that you factored it as far as it will go, and we don't want any complex numbers, imaginary numbers, in the factors themselves, only real numbers. So irreducible factors would look something like this if they're linear factors. Of course, linear factors have a degree 1x in them, so these are linear factors, and quadratic factors have a degree 2x in them. All right, so this factor right here, of course, could not be factored any further. That would be different if this was a minus there. This one here cannot be factored any further. So these are irreducible factors. So that's the first step, factor the denominator into irreducible factors. Next, after we've factored the denominator completely, we want to create our setup that we're going to work with. So our given fraction we put here, and then our factors we put in the bottoms here. We got to figure out the form of the numerators here based on the degree of our factors that we're putting in the bottom here. All right, if you have a linear factor in the bottom, you'll have a constant in the numerator. These are all linear factors. You're going to have a constant in the numerator. So that would be the form of any fraction over here that had a linear factor in the denominator. A quadratic factor in the denominator will have a linear expression as a numerator. So if these are quadratic denominators, then they'll have linear expressions as your numerators. There is one confusing thing that confuses people when we're first learning how to do this, is even though you may have a x squared in the denominator and it appears to be an irreducible quadratic factor, it is really a linear factor like this of multiplicity 2, and that takes a constant as a numerator. I will have to keep that in mind. So the bottom line here is we want to have a setup here to work with, and these are the ground rules for making this setup. This will become clear as we actually get into an example. So let's look at this first example here. So we're starting out with this 20 over x plus 2 times x plus 3, and we want to find the partial fraction decomposition of this fraction. So I'm going to write it on the left-hand side, and then I'm going to say on the right-hand side that I have this linear factor, x plus 2, as the denominator of one of these fractions, and I have this linear factor, x plus 3, as the denominator of the other one. All right? Now, back on this other slide over here, I said that if you have a linear factor, then you have a constant in the numerator. So I've put an a as the numerator of x plus 2 and b as the numerator of x plus 3. All right? So now I'm going to use the rules that I already know. In order to get this into one fraction, that means I need a common denominator. Here's my denominator, x plus 2 times x plus 3, that I'm going to attempt to get in both of these fractions. In order to do that, I'm going to multiply this fraction by x plus 3 over x plus 3, this fraction by x plus 2 over x plus 2. All right, so I've written out, in order to save time in the video. So now if I go ahead and carry that out, I've got this line right here. In the numerator, I've got a times x plus 3 and b times x plus 2, where you can see I have a common denominator all across the board. All right, so we're just going to simplify that a little more. I've carried out the distributing here. A times x plus 3 is this, and b times x plus 2 is this. All right, so now I'm going to go ahead now, since I have a common denominator right here and right here, I'm going to make it into one fraction on the right-hand side. So my numerator is all of this here, all of this here. All right, so now I've got two equivalent fractions with the same denominator. So that means the numerators are equivalent in order for this to be an equality. So I can write an equation using only the numerators. All right, so that's where I'm going to start up. So using only the numerators, 20 is equal to ax plus 3a plus bx plus 2b. All right, so now I know that if I have a constant on the right-hand side, that the constants, a constant on the left-hand side, that the constants on the right-hand side must add up to 20. So I have a 20 on the left, so that means that I must have 20 on the right. So 3a plus 2b must add up to 20. All right, now let's look and see whether I have any x terms on the left. I don't, so I'm just going to put a pink empty right there. So that's basically 0. So 0 has got to add up to a plus b, only the coefficients. I'm going to only work with the coefficients. So the coefficient of the x term on the left, basically, we can write that in there. So let's just write 0x in there for clarity. So the coefficient of that term there, 0, has got to equal a plus b. Now, why just the coefficients? Let me just remind you real quickly what I'm talking about. So this little red equation down here, if I say 0x is equal to ax plus bx, I really don't need those x's in there to have a true equation, because they can be divided out. So I'll just have 0 is equal to a plus b. So we're going to leave the x's out of our equation and only have equations in terms of the coefficient. So now I'm going to write a system of equations. I'm going to say 0 is equal to a plus b, and then the green ones, I'm going to say 20 is equal to 3a plus 2b. and this is a system of equations. So we learn how to solve a system of 2 by 2 equations here, a 2 by 2 system of equations. So we're going to employ that skill now. So I can either use the elimination process or the substitution process. Since this is a fairly small system of equations, let's just go ahead and use the substitution process. So I can say A is equal to, if I subtract the B over to the other side, minus B, which is going to allow me to substitute negative B in for A in this equation. So I can say 20 is equal to 3 times negative B plus 2 times B. And then if I combine like terms right here, I've got negative 3B plus 2B. So let me just save some room here. That's going to equal to minus B. Negative 3 plus 2 is negative 1. So this is negative 1B. So this tells me that B is equal to, let's scoot it up a little bit. B, that's a B, is equal to negative 20. All right, so I have a B. All right, so from there, I'm going to find out what A is. So if I look at this equation right here, I have A is equal to negative times B. So that must mean A is equal to, see if I can fit it in here without hitting my page change button. A is equal to the opposite sign of B, so that would be positive 20. All right, so we found A and we found B. All right, now let's go back and look up and see what we want to do with that A and B. So I'm going all the way back up to the top here, and what we want is we want to write our sum of the two fractions. Let me just highlight those. So I want to put the A and the B right here, and we want to write this form, all right, without, of course, this stuff here. So this is what our answer is supposed to look like. All right, so let's go down here and write the final form of our answer. So the final form of our answer is going to be 20 over x plus 2 minus 20. Let's go back and see if I got it in the same order. So what I'm checking for is that I don't accidentally put the x plus 3 first, because you've got to match up your A's and your B's to where you started out. If I said A belongs with x plus 2, then I wouldn't want to put the B over the x plus 2. The A goes with the x plus 2, the B goes with the x plus 3. So you got to check that before you write out your final answer. So A goes with x plus 2, and B goes with, so B, you could write it, put the negative in between instead of on top. So what I mean is, instead of writing it like that, write it like this generally. Either way is correct, however. And then x plus 3 goes on the bottom. Okay, so this is how you broke it up into two fractions. This is how it's going to look. So this right here, whoops, is your final answer, broken up into two fractions. So that's the technique. Let's try another example. All right, so we have find the partial fraction decomposition of this thing here. Okay, so it's got a quadratic expression in the denominator right now, and we want to check and see whether that can be factored any further. Okay, so we actually want to do the factoring. So I'm going to say that 5 times 6 is 30. So the ways to make 30, so remember 5 times 6 is 30, are 1 times 30, or 2 times 15, or 5 times 6. And they have to add up to negative 17 and multiply to give positive 30, which means I need two negatives. So they're going to have to go here and here. All right, since I have a leading coefficient of 5, I'm going to have to factor by parts. So I'm going to put the two middle terms in and factor by parts, like that. All right, so my 5x is my GCF of the first two terms. Bring down my sign. 2 is the GCF of the second two terms. Bring over your x minus 3 and check to make sure that makes sense. 5x times x, 5x times negative 3, negative 2 times x, negative 2 times negative 3. So my factored form is x minus 3 times 5x minus 2. Okay, so these are my irreducible linear factors in this case. So now this fraction that we started out with can be written in this form here. So I have two linear factors, x minus 3 and 5x minus 2. So I want to set up an equation that looks like this. All right, so it looks like this. These are two linear factors with multiplicity of 1, so I represent them 1 time, 1 time. Since this is a linear factor, I know I'm going to have a constant in the numerator, and same here, except we use two different letters because they're not going to be the same number necessarily. All right, so now we have a setup. So now we use our technique of finding the common denominator. So I'm going to multiply by these forms of 1 here in order to get common denominators all across the board. So now we can simplify that. Now let me just caution you that this may seem like a lot of writing to take down in your notes, but I recommend strongly that you write all these steps down in your notes so that you don't have to rewatch the video or rely on your memory when you're trying to do your homework problem. Because I've seen that going on. I say, well, show me that you've written this down, and then there's nothing there, and people can't remember the steps because there's a lot of them. All right, so write all this down in the steps, and that way when you have your test, you'll have your fully written out stuff. It'll be right there. Okay, so I've simplified this so far. I'm going to simplify it one more time by carrying out this distributing here. So here we go. I've gone ahead and simplified this all out. So 5a is the coefficient of the x term here. I've written it like this, then minus 2a plus bx and minus 3b right here. All right, all over the one denominator. Okay, so now I'm going to make an equation using only the numerators. So I've got my equation now, and from this equation, I'm going to set up a system of equations to solve based on the coefficients of the terms on both sides. So I'm going to use my highlighting again. So I'm going to highlight the coefficients of the x terms. So negative 4 must equal 5a plus b. And then in another color, my constant terms, negative 14 must equal negative 2a minus 3b. Now I'm going to write my system of equations. So the top equation is my pink, and the bottom equation is my green. All right, now I can solve this system of equations for a and b. This is a 2x2 system of linear equations. So since it's a rather simple system, I'm just going to use the substitution method. So if I solve for b here, I'll say b is equal to negative 4 minus 5a. And then I'll substitute for b in this equation here, so I'll have negative 14 is equal to negative 2a minus 3 times b, where b is negative 4 minus 5a from above. All right, so now I can solve this equation here, which is now only in terms of a for a. So negative 14 is equal to negative 2a plus 12 plus 15a. So negative 14 is equal to 13a plus 12, or negative 26 is equal to 13a, so that means a must be negative 2. So we have a. All right, now we're going to substitute a into the equation that we have for b, and we'll have b. So I substituted negative 2 in for a, And then I get negative 4 plus 10, which is 6. So that means B must be 6. So I have A and B. So now we go back up to the top and we see A goes with the x minus 3 factor, and B goes with the 5x minus 2 factor in the denominator. So we write our final answer as, let's make some room here. So like I just mentioned, you got to get your A with the right factor that you started out with, and then B. So this is what our partial fraction decomposition of our original fraction that looked like this ended up being. So I'm going to end this part of the lecture, and I'm going to make another recording of 3 more examples so that you're fully prepared for carrying out your homework assignment. So stay tuned for part 2 of the lecture for 8.6.